Server virtualization. Everybody's doing it to reduce data center sprawl and energy costs, to simplify manageability, and to improve utilization, business continuity, and disaster recovery. But there's more to virtualization than just taking any old server and slapping in some VMM software. That's why Intel designed Intel Virtualization Technology, or Intel VT. What is Intel VT, you ask? I like to think of it like this. Consider the major components of a server: the processor, the chipset, and the network interface. The individual technologies that make up Intel VT are built into these components to provide comprehensive hardware assistance that boosts processing performance and I/O throughput while increasing security, reliability, and flexibility. Let's take a closer look, starting with Intel VT and Intel Xeon processors, also known as Intel VTX. One of the major Intel VTX components is Intel VT Flex Migration. Why is it important? Well, in the world of virtualization, you need to be able to migrate applications from one physical server to another. Migration is really important when it comes to balancing workloads, performing routine maintenance, or recovering from unforeseen disasters. Until recently, though, migration has often been a pain in the... Problem has been that live migration wasn't possible across different generations of servers. A newer processor here, an older one there, and you were flat out of luck. You could only migrate between servers with processors of the same generation. Not exactly a real-world scenario. With Intel VT Flex Migration, you can migrate applications live while they're running across physical servers, even servers that are built upon different generations of Intel Xeon processors. The result? You can react more quickly to changing conditions, making it much easier to keep your servers and your business up and running. Another processor-based feature is Intel VT Flex Priority, which improves processing efficiency. Have you ever tried to get your work done while constantly getting bombarded with interruptions, many of which aren't even critical? It's pretty tough to do. Intel VT Flex Priority is kind of like having a receptionist who alerts you when a request is critical, while delaying requests that are less urgent so you can work more efficiently. Similarly, your servers can work more efficiently when they aren't interrupted all the time, as our little friend here can attest. But Intel VT encompasses more than just the processor. Another key piece of the puzzle resides on the Intel chipset. Intel Virtualization Technology for Directed I/O, or Intel VTD. It serves as a hardware assist that reduces the need for VMM involvement and thus processor involvement in directing I/O throughout the server. Think of the typical virtualization scenario where almost all data movement is controlled by the VMM, which means your processor spends a lot of time as a traffic cop, just directing data flow. With Intel VTD, a hardware assistant creates direct data paths between the physical server's devices and the virtual machines running on it, so that most data movements can happen without any VMM or processor involvement at all. Intel VTD results in faster I/O and improved processor utilization, since your servers can focus on your applications and not the overhead of data movement. And finally, there's Intel Virtualization Technology for Connectivity, or Intel VTC. Intel VTC uses hardware assists residing in the network adapter to handle I/O related tasks, enabling faster I/O while freeing processors to focus on job one, running your applications. Without Intel VTC, your server's processors are forced to spend part of their time on the overhead tasks of packet sorting and routing so that each virtual machine receives the correct data. Very inefficient. And then, when the application is ready to send back the data onto the network, the same inefficient sorting and routing processes happen in reverse, with the result that one virtual machine's outgoing traffic can interfere with that of another virtual machine. With Intel VTC, though, it's like adding dedicated assistants to handle those overhead functions. One assistant, Intel I/O Acceleration Technology, or Intel IOAT, accelerates data transfers across the platform by offloading a lot of the network packet overhead that the processor would otherwise have to perform. Meanwhile, another assistant, Virtual Machine Device Queues, or VMDQ, sorts the data and routes it to the right virtual machine, streamlining the data flow on a priority basis for a quick and smooth transmission. These Intel VTC hardware-based assistants greatly reduce processor overhead while speeding data to and from your applications. More gets done, more quickly, which, after all, is why you bought servers for your business in the first place. As you can see, there really is a difference, and a big difference indeed, in virtualizing on Intel Xeon processor-based servers with Intel Virtualization Technology built in. For more information, visit www.intel.com/go/virtualization.